Okay, so log functions. Okay, and again, a lot of this, guys, is just review because we're trying to get ready. I'm trying to get you kind of your mind back in the mode to get ready for the more the CPM stuff, which is where we actually start modeling this stuff, okay? Applying it to like real world situations, but we got to review the basics so that we know how to solve these. Okay. All right. So logarithms. Now, there's different situations you're going to face, but this case, hang on just a second. That's my bad. Okay. So logs. Now, if you have logs on both sides of your equation, your goal is to cancel them, to get rid of the logs, okay? So logs on both sides, and remember, when I say both sides, I'm talking about the equal sign, right? So if I divide this equation in two through the equal sign, which I'll kind of highlight my divider there, logs on both sides, the goal is to then cancel the logs. All right. Now, if you only have one log on each side, just one. In other words, on the left, I literally just have one log expression. And over here, I only have one. Right away, I can cancel those out. Okay. So right now, I can cancel this log and cancel this log, because if these are both the same base and they're both log, that means that what's inside of that log and over here have to be the equal. So now I literally just cancel that out and write 5k minus 3 equals 17. Remember, this is the A part of your log. So you're just left with the A. And now we just solve that. So now add 3 both sides. That's 20. Divide by 5. And we get 4. Okay, equals 4. Okay, so if we got logs on both sides, again, the goal is to get to one log on each side. Okay, not every one of them is going to have just one log. Okay, so let's say, let's start with this example. I'm going to go log 9 plus log of x plus 7 equals log of 32. Now, guys, do you remember what this little number is called? What's that little number called? Well, let me write in what it is. Okay, so log, that number on the bottom, we call the base. It's the B. Okay, then the number attached to it is your A. Okay, and then we would say if it was equal to just one number, that's the exponent. Okay, so right now, if there is no base written, what is it automatically? It's 10. Good. So B equals 10 if not written. So it's kind of like, you know, if you just have a variable by itself, like x, you know that there's a 1 in front if nothing's written, okay? Or a square root, okay? A square root, that little number on the top is automatically a 2, we just don't write it in, okay? So for logs, again, that number right there is automatically a 10, all right? Now, like I said, we have to have only one log on each side in order to cancel them. But right now, we have more than one on the left side. We have 2. So we have to combine these together, all right? Okay, so if you are adding 2 logs, do you guys remember how to combine these? What do I do with these, with the 9 and the x plus 7? I can combine them into 1 down here, but what is it? How do you combine them? You don't add, because when you add, you do something, and when you subtract, you do something different. It's not divide, it's multiply, okay? So if you have multiply, I'm sorry, not multiply. If it's log plus a log, okay? All right, actually, no, sorry, my bad. Let's do this. Let's do log of A plus log of B. This is equal to log of A times B. So basically what you do is you take the first A or first A value and you take the second one and you multiply them, okay? Now, if it's minus, let's say log of A minus log of B, you guys know what we do there? Right, and which one goes on top of the fraction? The A or the B? A. Right, the first one. All right. Okay, so for this one, what are we going to do here? We're going to multiply these two or divide them? Multiply. Because there's a plus right here. We're adding the two logs. So now it's 9 times x plus 7. And I'm just going to kind of double up the parentheses just so that you guys can see that we have to multiply those two first. And then nothing changes over here. Like we're not changing this. Okay, we're just bringing those together. Okay, now you notice that we have single logs on both sides, right? So now we can drop these off. Okay, once you have a single log on both sides, now I can drop that off. Now I just have 9 times x plus 7 equals 32. And now we just simplify and solve that. Okay, so I'm going to distribute the 9x. 9 times 7, 63 equals 32. And then just work through the steps. Okay, try to get x by itself. So I'm going to subtract 63 first. 32 minus 63, how much is that? Negative 31. Negative 31, okay. All right, and then divide by 9. And x is equal to negative 31 over 9. Okay, and there is nothing wrong with having a fraction. Some of you guys think something's wrong when you get a fraction. It's okay to get a fraction. All right, a lot of times, especially with these log type problems, you're going to end up with a fraction. Okay, so I'll pause for a second. So now with complex numbers, you always got to remember that complex numbers have two parts, and that's why they're complex. You have a real part, and then you have like this imaginary part, all right? Okay, so the first part we call the real. And then it's going to be added, or it could be subtracted, added to a complex or imaginary part. All right, so basically when you are simplifying or solving these types of problems, just make sure that you separate the two. Don't add them together. Just like, not like terms that are not like terms, you wouldn't add them together. You almost treat the I like it's a variable, like if it was X or something, okay? The only difference is when we multiply it, then something special, something different happens. Okay, so here, what do you guys think the first step here is? What should I do to simplify this first? Yeah, okay. Before I combine anything that's like term, I've got some signs. I got to do something. Distribute what? Yeah, distribute that negative. Okay, I want to distribute that -1 that's right there first, and then we'll combine like terms. Okay, so first I'm going to distribute that there. So a plus 4i. So -1 plus or times -3 is +3, and then -1 times -2i is +2i. Okay, and then like you said, now we're going to combine the like terms. Okay, so we have 8 plus 3 is 11. Okay, now which part is that? Is that the real or the imaginary part?
Real.
That's the real part. And then we're going to add the imaginaries together. Okay, so that's the complex number. You got a real part and then you got an imaginary part. In some cases, you might not have only one. You might only have an imaginary part, or you might only have a real part. Oh, looks good. All right, so I'm going to flip on over to the other side here. 4. Make myself a column over here for notes. Okay, so this next one, I'm going to do 7i minus, or 7 minus I, and then 8 times 8 minus 4i. All right, so now we're going to multiply complex numbers. Multiplying. All right, so we got 2 binomials, 2 numbers here, 2 numbers here. What's some ways we can multiply this? Give me some methods. Do what now?
Multiply 7 and 8. Negative I and negative 4.
Okay, so you're going to do first, the last. What else you got to do? There's 2 more you got to multiply. Okay, well, what you're thinking of is you could FOIL, right, where you do the first numbers. The O is the outside numbers, you multiply those. And then the inside, the 2 inside, and then the 2 last. So that's one method. What method have we been using in this class to multiply 2 of those? What? We use it to factor, but we're not factoring now. We're actually doing the reverse of factoring. We're going the opposite way. Okay? Or this guy, the box, okay? We're doing the same thing, it's just the box sets up the FOIL for us. It sets up all that multiplying, all right? So here, where do the numbers go, on the outside or inside? Outside, so 7 minus I. All right, now when you guys watch Miss Menard, she likes to put the numbers on the bottom. I just, visually, that messes with my head. I like to put it on the top, okay? Now it still works. You can do it either way, but I like to go up here. She says she likes to put them on the top. I'm like, that just messes with my brain. So I know for some of you guys that messes with you too. So, I mean, it doesn't matter. You'll get the same answer, okay? If you like it on the bottom, great. If you want it on the top, great. Just as long as they're not like across from each other. All right, so let's now multiply every term. So 7 times 8, 56, negative I times 8, negative 8I. 7 times negative 4I, negative 28I. And then negative 4 times negative I, it's going to be positive 4I squared. All right, now let's write those out. So I'm going to start with the real part, 56. And then we have some like terms in there. So remember, these are like terms. So negative 8 plus negative 28 minus 36I. And then plus 4I squared. Now, there's a special property when it comes to I. And first of all, we need to remember what I even equals. I is the square root of what number? You guys remember? And this is the whole reason why it's called imaginary. And what numbers can we not square root? You can't square root 0, because 0 times 0 is 0. Negative numbers. So if like I took the square root of 9, well, that's 3, because 3 times 3 is 9. But if I do the square root of negative 9, there's not just one number I can multiply twice, because in order to get a negative, one has to be positive, one has to be negative, right? So it can't do negatives. So an imaginary number, I is equal to the square root of negative 1, okay? Now I squared, which means you're going to do I times I, which also means you're going to do the square root of negative 1 times the square root of negative 1. Well, that is equal to, when you multiply two square roots or two roots with the same index, you can multiply the numbers inside together, like that. So negative 1 times negative 1, which is positive 1, which then means it's equal to 1. So after all of that, you need to remember that I squared equals 1, right? So that means that right here, this 4 is no longer 4. I squared is just 4, because it just becomes 1. So I squared equals 1. So literally this is going to become 56 minus 36i plus 4, which means now you've got these two like terms, which will combine. That becomes 60 minus 36i. Okay, so that's the main thing you're going to deal with on those imaginary problems, is when you multiply the i's, just make sure that becomes 1. Okay. You don't have to remember all of this, or just explaining why, but just remember I squared equals 1. So once you multiply the i's, that'll give you a 1 at some point. Okay. Let's say, for example, that the function they give you is, let's say f of x is equal to 2x cubed and then minus 5. All right, so we're finding the inverse function. I'll just put f of x to represent function. All right, so the way you want to approach this, the way I like to do it, is I like to say, if I'm going to plug a number in to the function, what do I do first to simplify? So let's just say, for example, plug in, I don't know, 4. I plug in a 4. So I'm going to plug a 4 into that function, right? So plug a 4 right there. Now, what would be the first step to simplifying that? What would I do first? 4 cubed, right? I would cube the input. Okay, so that is what I write here first, cube. Or I can write x cubed, which basically means the same thing. I'm taking that number and I'm cubing it, okay? All right, so that's step 1. So does anybody know what 4 cubed is? 4 times 4 times 4? Mm-hmm. All right, so that's the first step. What would be the next step?
Multiply.
Okay, multiply. Multiply what?
64 by 2.
Okay, so you're going to multiply. Okay, 64 by 2. So that means up here, my next step would be to multiply 2. All right. So that times 2, 128. And then what's the last step here?
Subtract 5.
Right, subtract. So up here, my last step is to subtract 5. All right, and then I'd end up with 123. The point of that is to just figure out what operations did you have to do? What did you have to do to get, after you plug that input in, to get to the end? Once you have those, then now you can create your inverse, okay, which is like almost like we could call it like a backwards function. Okay, I don't know if you guys are like DC comic fans, but anybody know who's the opposite of Superman? Anybody know? Oh, come on. Anybody in the Superman? No? Bizarro? Forget you guys. You guys watch Flash? I know somebody watches Flash. Who's the opposite of Flash? Huh? The guy in the yellow suit. Oh, what's his name? Reverse Flash. It's because Reverse Flash, right? Yeah. Come on now. So that's what it's like. This is basically you're finding the reverse function. All right, so here's how you do this. To find the function, go in reverse and go back and pick the opposite. So I'm going to start with the -5. But what's the opposite of subtracting 5? Add 5. Then I go to the next one. What's the opposite of multiplying 2? Divide 2. And then what's the opposite of cubing something? Not square root, but cube root. Got the right idea. It's a root, but we're going to cube root. So this is how you're going to create your function. Okay. So now I'm going to say, okay, the first thing I do to the number is add 5. So I take x, bless you. I take x and then add 5. Okay, what's the next step? I would divide that whole thing by 2, everything. And then after I take the number, add 5, and then divide it by 2, I would take whatever I get and then take the cube root. So over this whole thing, I put that cube root symbol. Okay. Now I should have left room. I shouldn't draw this arrow here. I'm going to draw an arrow like this because I wanted room to be able to put the notation like this. So here I put f of x equals, but does anybody remember what the symbol I put there is for inverse?
-1.
Mm-hmm. A -1. Okay. Chase, where you been all my life? Where you at in quarter 2?
Sorry?
Making that turnaround this year? Yeah. All right, let's do it then. All right, so that's inverse. Okay. I'm not going to do an example for quadratic formula. I'm just going to talk about it, talk about the formula real quick. So let's see, how can I do this? Let's go over an example from Desmos. All right, so I'll give you guys a second to copy that real quick. Let's pull up. I know for some of you guys, I'm throwing a lot at you. It's like 4 different topics all in one. All right, so, but I know I'm not going to see y'all until next week. So make sure you guys are good to go. Oh, wait, I'm searching the wrong bar. Quadratic formula. Here we go. I'll say decimal answer. All right, so solving equations like this. Now, the whole reason for this, and you guys don't need to take notes on this, the whole reason for the quadratic formula is if you can't factor, right? So let's say I try to factor this problem. and I'm doing the x. Try to figure it out. What two numbers multiply to 50, add up to 17. So I'm going through the list. I'm like, okay, 1 times 50, 2 times 25, 3 doesn't work, 4 doesn't work, 6, 7, 8, 9, 10 times 5, that's all I can come up with. But none of these add up to 17. So it's not going to work, right? It's kind of like that one problem like a couple days ago where it was not factorable. Okay, so there has to be another method if we can't do the factoring. All right, and that's a quadratic formula, which looks like this. So that probably looks familiar now. So remember that your A, first of all, before you even plug in your A, your B, and your C, you got to make sure that the equation is equal to what? Equal to 0. So before you even start anything, make sure this equals 0 over here. Okay, I remember a quiz question last quarter where it was not equal to 0. So you had to like add a number or subtract it to get it to be equal to 0 first, right? Then the coefficient or the number in front of your x, that's your A and B. And then you have your C. And then now we're just plugging them in and simplifying, okay? The biggest thing here is that B, okay? If you got to remember, it's already has a negative on it. So if your B is negative, make sure you're multiplying the negative times the negative, okay? That way it will become positive there. All right, so here I plug in my 17 for the B, and we square that. So we'll start with the square root, and we simplify in here, so I square that. Then I subtract 4 times 1 times 50, which is 200. So it's a really big number, but after I subtract, then I end up with 89. And then the key step here is to remember that it's plus and minus. So I want to split those into 2 different solutions, okay? So one where I'm adding the square root, and then one where I'm subtracting the square root. Now, one thing you guys can do is Desmos is really helpful with this. So if you guys can at least set this up in the formula like that, you can use Desmos for the rest. I wonder if this will actually let me copy. I can make it easy on myself. No, it won't. Okay, so Desmos, that's the thing of why I like it. First, I hit the divide button. That way I get that little subtraction, I mean, not subtraction, but fraction symbol. And then I can just type out the whole thing. Now remember, the first one, I'm gonna add or subtract, whatever you wanna do first. And then square root, then hit 17 squared, just basically type out the whole thing, right? Kind of automatically sets up some of these parentheses for you. And on the bottom, it was just 2 times 1. So there, it simplifies it all for you, and then you can go straight to your decimal answer and round it, okay? And then what's the only thing I need to do differently on the next one? To get the second solution. Right, all I gotta do is change this plus into a minus. Okay, and then there's your second solution, just make sure you round correctly, okay? So if let's say I ask you to show work, what I wanna see is you set up the formula. If you don't show all the steps after that, that's fine. But what I wanna see is you set up the formula, because I know that some of you guys might use Desmos just to set it up and then plug and play, okay? All right, you guys at home, you guys are free. Have a great weekend. If you got questions, stick around. Otherwise, see ya. You guys that are here, I want you to start on the worksheet for this topic today. In particular, let's start with the logs, because people always kind of get stuck on those. All right, so let's get some practice on that today. If you don't have your packet, you head over to the library. Just as you go in, check in, and then it'll be right to the right, okay, as you walk in.